Hi, everybody. If you're watching this video, that means you have already completed step 2, mathematical description part 3, meaning you have already written your rotation rule into your spreadsheet, like so, right here. Then you perform the rotation transformation on your new domain, which are these points. That's performing the transformation. You have hit submit and turned in your updated spreadsheet. And so now you're ready to prove the properties of rotation. So there are 2 properties of rotation that we will walk you through. Go 1. You are going to prove the distance from the center of rotation to the pre-image, or the corresponding image points to the center of rotation. The distance there is the same. So prove the distance from the center of rotation to the pre-image point or the corresponding image points are the same. So there's going to be 2 lines that you're going to be looking at, and you're going to measure them to see if they're the same. Okay? In goal 2, you're going to prove that the angle of rotation is your chosen angle of rotation. So my chosen angle of rotation was 180 degrees. So I'm going to prove that my angle of rotation is 180 degrees. If you chose 90 degrees, you're going to prove that it's 90 degrees or prove that it's 270 degrees. How do you do that? We use slope to do that. If the slope of the line segments that we find are perpendicular, then your angle of rotation was either 90 degrees or 270 degrees. But if the slopes of the line segments that we're going to find are parallel or the same, that means that the lines are parallel, right? That means that our angle is 180 degree rotation. 180 degree rotation. The video that we're making is going to go right here for you. Okay, so that's where you're going to find this video right here. I think it's funny that I'm saying that because you're watching the video and it's not there right now. But anyway, so step 1, you're going to pick a point on your new domain. 2, you're going to find the distance and the slope from the point on the pre-image to the center. Step 3, you're going to identify the corresponding point on the image. Step 4, you're going to find the distance and the slope from the point on the image to the center of rotation, which is always 0, 0 for us, okay? Step 5, you're going to use the distance to show that both points are the same distance from the center of rotation. Step 6, you're going to use the slope to show the angle measurement. So recall what I said before. The way we use the slope to prove the angle measurement is if the lines are parallel, that means the slopes are the same. That means that the angle of rotation is 180 degrees. If the lines are perpendicular, that means that the angle of rotation is either 90 degrees or 270 degrees. All right, so let's get to work. So I'm going to keep it pretty simple, right? Remember in the previous videos, I used point E, right, and F for my math. So I'm just going to continue to do the same thing so I don't have to, think about new points. So I'm going to use E. So this is going to be my E for this rotation, and E prime, because this is the pre-image for the rotation, is going to be the points -2, 0.41667. So my image point is going to be 2, -0.41667, and my pre-image point is going to be -2, 0.14667. So like I did in the previous video, I'm going to take a picture of these points so I do not have to keep flipping back to make sure that I wrote it down and to do the math. All right. All right, so we're ready to do the math. So my first point is -2. This is E prime. Excuse me, this is E. -2 0.417. My second point is E prime, 2, comma, negative 0.4167. And so now I am going to find the slope and the distance. So my other point that I'm going to be thinking about is the center of rotation. And the center of rotation is going to be 0, 0 for us. Okay, so the first line is E to, let's call the center of rotation P. We're going to call it P. So E to P, that's my first line. And then my second line is going to be E prime to P. Okay, so let's call that the second line. And we are going to find the slope and the distance. All right, so let's start with the slope. Remember, slope formula is y2 minus y1 over x2 minus x1. And a distance formula is going to be square root, right, x2 minus x1 squared plus y2 minus y1 squared. All right, so let's do it. Let's go ahead and label our points first. Hi, everybody. So I'm going to show you the property on your actual picture that we are proving for rotation. Okay, so first things first, I'm going to turn off the other graphs so we can look at the rotation in its pre-image. So I'm turning off the pre-image. All right, I'm turning off the translation for myself because that was my other one. The pre-image for my rotation was a dilation. So I'm going to keep that one on along with my rotation. So I'm going to keep those two on so we can look at those. Okay, I'm going to go ahead and move this graph, my original picture, out of the way so I can look at my picture carefully. Okay, everybody, so let's look at the graph to see exactly, get a visual of what we're proving, okay? So remember, for rotation, you have to prove that the line from the pre-image to the center is congruent or the same distance as the line from the image to the center. So our point was point E. So A, B, C, D, E. That was this point right here. So we're going to locate that point. And then we are going to compare it to its corresponding point. So -2 and then 0.4167 means that our point is right here. So the corresponding point to that would be right here. And so we're going to look at the distance. This is from the center of rotation. Let's make that line as straight as possible. It's a straight line from the center, from the point to the center here. All right, and I'm going to do the other part in a different color. So we're looking at this distance right here. So the question is that the same? That's what we're trying to figure out. So you're using a distance formula on this part, distance, and you're finding the distance on this part, distance. And when you find those distances, you're going to see if they're the same or not. So are they the same? Question mark. That's what you're trying to figure out. Here's the other thing you need to figure out. Remember, we need to find the angle of rotation. So as you can see, this is actually a straight line. And what is the angle measurement of a straight line? 180 degrees, right? But you can prove that with the slope. So if the slope is the same, then you know that the line is a straight line, which makes it 180 degrees, right? Because the slopes are parallel, but it actually is supposed to be parallel because it's actually the same line. So remember, to find the slope, you do rise over run. So you're doing rise over run here, and you're doing rise over run here with the formula. And you're checking to see if that slope, if it's going to be parallel, okay, or perpendicular. Remember, if it's perpendicular, then your angle measurements 190 and 270 or 270. But because mine are going to be the same, that means my angle measurement is 180. All right, so this is the slope of this line, and you need to find the slope of this line. And in the case of me, we want to see, are these the same? In the case of 90 and 270, you want to see, are those perpendicular? Meaning, are they negative reciprocals? Okay, so that's a visual of what you're proving, the two things that you're proving. All right, so here we go. Let's go ahead and label our points. We're going to call this X1, Y1, and let's call this X2, Y2. So E and P are the points that I'm looking at. So this is E, and remember we decided to call the center P. So we're going to say X2, which is 0, minus X1, excuse me, let's do the Y's first. I forgot that goes on top. Okay, so here we go. Y2, which is 0, minus 0.4167, which is Y1. And then in the denominator, we're going to do X2, which is 0, minus a -2. And then we're going to find that number right there. I'm not going to work it out because I want you to work it out. Make sure that you understand what you're doing. All right, then over here, we're going to do the same thing. All right, let's label our points, this time in blue. We're going to call this X1 for the second line and Y1 for the second line. All right, let's set it up. Y2 minus a negative 0.4167 and 0 minus 2. And then you're going to find that slope there. So remember, if these slopes are the same, that means the lines are parallel. And if the lines are parallel, that means I have proven that the angle of rotation is 180 degrees, which is what I wanted to prove. But if the slope comes out perpendicular, then, and your angle measurement is 90 or 270, then you have proven that the angle is 90 or 270. So if these slopes do not come out either parallel or perpendicular to match our particular angles, that means we did something wrong and we need to check our math. All right, now let's go to the distance. So we're going to find the distance from this point to the center. So let's start with the first one. Square root and I'm just setting it up. Okay, so my x coordinates, x2 was 0 minus a -2, and my y coordinates were 0 minus 0.4167. And we go ahead and do that math. And like I said before, I'm not going to work it out because I want you to work it out. But I am showing you how to set up the work. All right. And remember to use Desmos because it does make it easier when you're working this stuff out. So then for the other one, we're going to do, again, let me just set it up. Okay. So my x coordinates were 0 minus 2 and 0 and I need more space, minus a negative 0.4167 squared. So then I'm going to check for that distance. So here's what you need to know about the angle of rotation. That distance should be the same. Okay, so this number should be equal to this number when you find it. If they're not equal, then we might have done something wrong. Okay? Now you are ready to submit your work. I am so proud of you. You have finished part 3 of step 2 in your project. Thank you.